Right. So let me know if you can see the screen. You can either type in chat or you can unmute yourself and. Can you see my screen?
Yes, sir.
Right, perfect. So I'll start by introducing myself, right? My name is Basil Abdul Majid, and I'm working with Mega Lecture. I have my major in theoretical physics from NUST. And so let me just also write these things down here, right? So I'm Basil, and I have my degree in physics, specifically theoretical physics from NUST. And I have around 5 years of teaching experience. Right. So I got into physics because I really enjoy doing physics, right? And so why do we do physics? That's let's start off by the question that why do you do physics, right? Uh, Many people will give you many different kind of answers, and you might be able to relate with them, you might not be able to relate with them. You're doing your O levels, right? So I think this is the first time that you have been specifically introduced to physics, right? So science has been divided into 3 parts. So, well, why do I do physics? Let me frame the question in that way. I don't do it for the results, right? So it's not, well, of course, it is about the results. By results, I mean when you do your calculations in physics and you get some results, and then you find interesting laws and everything, right? But I do it for something else, and that's just personal satisfaction when you're finding about things, right? So there's a pleasure in finding about things, and it's an innate curiosity, right? So we humans have innate curiosity. When you're born, you have curiosity, you are curious about finding out about things, right? And so physics is the way to go about that, right? So I was interested in physics during my O levels as well. So I got into physics. I'll be honest, I started watching some videos on physics, some documentaries on Sir Isaac Newton, and from there I went to Einstein and then Feynman and so on, right? And that hooked me onto physics. And then I got some books, popular science books, and I started reading them. But that's just to get you hooked into physics. Real physics, when you start doing physics, you take courses like classical mechanics, quantum mechanics, thermodynamics, and then there are more modern courses like particle physics, quantum field theory, general relativity, and so on, right? So when you start doing them, it's you get some satisfaction, and that's why well, at least I do physics. That's why. And it will always enhance your thinking skills, your critical skills, how you have to, when you look at a problem, how do you tackle that problem. It will basically shape you in doing all these things, right? So I guess well, of course, this is just lecture 0, right? A demo class, as you may call it. I'll just tell you about the overview, how we'll be carrying out our classes, and how will we solve past papers, how will I respond to your questions and everything. So before I go any further, I would like to hear from you. Your well, let's just pin it down to where you guys are from, and when are you doing or taking your O levels? May, June, or October, November? So if you're hesitant to speak, I completely understand that, but it would be helping you to boost your confidence if you can just unmute yourself and speak as well, right? Or you can, if you're still hesitant, you can just type in chat, and we can do it like that. So anyone, any volunteer? Just a basic introduction. Just tell me where you're from, your name, if and when are you taking your O levels exams, which session? Okay, so we only have one person right now in this class right now. Umeza, if I'm pronouncing your name right. Okay, so I think nobody is willing to speak right now. You can type in chat. Maybe I don't see anything in chat over here. Oh, I'm audible. Am I audible? Wait, let me just check. There is this
Yeah,
chat.
you're all.
Yeah. Okay. Right. So here's the chat, and okay. Sorry. My name. Well, there is a problem in mathematics. It's called Basel problem. It's a series problem. You can relate it with that. You can even relate it with there's a city in Switzerland called Basel as well. And so I never really tried to dig into what my name means, but it's from those two parts, and then it means I think it means brave or something, right? What about you? What does your name mean, and how do you pronounce it?
It's Umeza, and it means beautiful and respected.
Right. Amazing. So you're studying your O levels degree in FPS. You'll be appearing in summer session, right? Okay, perfect. So I think my screen is unshared. Let me share that again. Right. So what do you plan? Do we have more people? No, I think okay. So, Umeza, what do you plan for your future? Do you have any plans that you want to do this thing or that thing? Or let me also phrase it in this way: are you passionate about physics?
Yeah, I used to enjoy physics mostly because it was towards astronomy, but I kind of lost that interest over the year. I had a terrible physics teacher in school.
Oh, right. Okay, yeah. So everyone has that experience one way or another, right? But well, let me also say this one more important thing, right? Uh, your knowledge is not limited. So you're learning right now. You're going through things. You're from your teachers. They're telling you about things and all. But now we're in the era where we have everything. You have access to all the books. You have access to YouTube, and so you can always increase your knowledge. is what I'm trying to say, right? So you can always learn about new things. And if I always say this thing, that when a person is born, they are born as a physicist, right? A physicist is someone who does physics, right? Because when you're born, you're curious, you want to explore everything. People, even kids, small kids, they break things and they're interested to see what you can say, they're interested to see what the thing is made up of. And they try all the experiments, right? And then unfortunately what happens is, the parents, they will sometimes they say that don't do this, or unless it's something really harmful for the kid. I like to think that you should let the kid do his or her thing. Anyway, um, so so that's this, right? Okay, so what we'll be doing is, I'll be giving lectures, right? So we'll follow this plan. Let me write it down here. So from Monday to Thursday, let's do this, that from Monday to Thursday, I'll be lecturing on the chapters, where we'll talk about, let's suppose that you have a first chapter. It's a very basic chapter, right? I think it's called measurements, and you talk about very basic things and all. So we'll start with that, right? And then we'll do some examples in the class. We'll even look at some of the problems in our class after we're done with the theory part of it in the class, right? So let's say from Monday to Thursday, we'll be more focused on the theory, right? And then on Friday, let's do this, that Friday I'll take all your questions. Let's not say I'll take, but I'll take you can always send your questions to me in the group that we have on WhatsApp, right? And I'll take all your questions, I'll go through them, of course, and then we'll discuss all of those questions in the class on Friday. We'll also be solving past papers and everything. We'll keep that for Friday, right? So all your questions will be answered on Friday, right? So what's more? Yeah. So, well, from questions, I would also like to say that don't ever hesitate in asking questions, right? So you have to ask questions when I'm teaching something, when I'm telling you about something. I've been a student as well, right? So I know that you don't understand each and everything that I'll be saying in class, that I'll be talking about. And even it might appear as though you understood it, but once you go back and you do your homework and everything, you might have some questions, right? So whether it's a question during the class, or whether if it's after, while you're doing your own thing and you have some questions regarding the topic, you can always ask me. You can post them in the group. During the class, you can stop me and you can ask your questions. So this thing, I always like to stress on this thing, that you should always ask questions, right? And never hesitate in asking questions. Because if you think about it, if Sir Isaac Newton, he did not ask the question, why does the apple fall and the moon does not fall, we would not be this far, at least, right? At this point of time, we wouldn't have been this far in uh, understanding nature, right? So that's also done, right? So remember, always ask questions, okay? So that I'll again stress on this point, that always ask questions. Okay, so apart from all of this, I'll also be giving you homeworks, right? So regular homeworks will also be given, so that you can, and I'll not I understand that you have other courses, other subjects as well. So the homeworks will not be lengthy. They'll be, let's just say, tiny, right? Even though it's a funny word, but homeworks will be tiny. So they will, of course, cover everything that we do in the class, but they'll not be too lengthy, right? So the same type of problem will not be repeated too much, right? So sometimes you have to solve a same type of problem at least 1 or 2 times, 2 to 3 times, right? But not more than that. And so that's about homeworks. And I'll also be preparing these homeworks will be prepared in the form of worksheets, right? So I'll be posting these worksheets in the group, and then you'll solve them. There will be a deadline, and you'll solve these worksheets by that time. And you'll have questions and everything. I think I'll do this. I'll share the answer sheet, or this, let's call it a solution manual. I'll be sharing the solution manual with you guys, and after the deadline has passed, right? So you can check, you can grade yourself, you can see what you did, and if you had any problem in the homework, then you can come to me, and we can discuss that in the class, right? So this is how we'll go about things. Let me just open. Uh, let me just Before that, let me see, is everything covered that I wanted to tell you? So yeah, so far this is it, I think. I want to hear from you if you have any questions regarding all of this thing that I told you we'd be doing. Is there any
Yeah,
question?
but actually, will we be provided with notes or some sort of, formula sheets before our exams or our tests? And will you be preparing us for our tests and our exams as well?
Yeah, so that's the point, right? So we'll be and that's why we'll be more focused on solving problems, right? So I think this is like a tuition for you, right? You are doing your O levels from a school or something, right?
I am doing my O levels from the school actually.
Yeah. So yeah, yes.
I'm actually kind of preparing beforehand, so that
Exactly,
I know.
exactly. Right. Exactly. So that's yeah, so that's the reason that we'll be focused more towards problems, right? Because of course everything that I'll be covering in theory, you would have an idea about it, right? But you might have some questions if you don't understand it well enough from your school or anything. You'll have some questions, we'll answer those questions. I'll go through the topics in my style, right? So we'll be focused more towards the problem solving, and hence of course that would prepare you for your tests, exams, and everything. And about the formula sheet, yes, of course, you'll be provided with a formula sheet. So was that just it, or is there anything else?
Not anything else, but in this demo, will you be covering some topic just so that I can know how you basically teach before I go any, ahead with this?
Right. Yes. So yes, of course, I will start with the very first and very basic chapter. It's of measurements. Let me open that file, and I'll show you how will we go about that, right? So just give me a second. Right. So can you tell me if this screen is visible?
Yes, it is.
Right. So, well, I thought of some ways, right? So I thought that first I was going to write down everything from scratch, right? And then, but the problem with that is it takes up most of the time while I'm writing something. The time is being, you can say it takes up most of the time, right? So I think the better way is to for example, let's say this is chapter number 1, right? So we have all the important things that are required to solve your problems. We have all of these things over here, and then we have examples as well, and I'll be going through these examples. I'll be solving these examples with you. And so it will be more like this. So you can see that we have these notes, and we'll be going through these notes, and then we'll be solving the examples. And at the end of that, once we are done with, for example, let's say we are done with this chapter 1, all the notes, we are done with this file, then we'll open some questions from past papers, and we'll be solving those questions, where I'll be sharing some problem solving techniques with you and everything, right? So, well, we have limited time left in this meeting, so we're working on that. I'll fix that by Monday, hopefully. So we'll be having our first official class on Monday, and I'll fix all these technical issues by Monday, right? Right now, the meeting might end in some time, so we'll have to deal with that. So it's a demo class, and uh, we'll start with this chapter 1 now. And of course, I'll not be able to complete this chapter entirely. We'll just start it so you can have an idea of how things are going to be in the future, right? So just let me know before I proceed. You can hear me clearly. There's no problem.
Yeah, I can hear you.
Okay, perfect. So yes, chapter number 1, physical quantities, units, and measurements. It's a very basic chapter. We have so before we dig into this table or whatever, do you have any idea what a physical quantity is? What is your perception of a physical quantity? Do we, if you have more students, of course, they can answer as well.
Physical quantities, basically those. I think. Well, I studied this last year, but um,
Yeah,
it is
just
those
whatever is in your mind.
units.
Yeah.
Um, yeah, they have units.
Right, exactly. So physical quantities, you use something, you have to use something to express your physical laws, right? You have to express the laws of physics, or as I like to call them, laws of nature. And that is what a physical quantity will do for you. And for a physical quantity, you have some units for that physical quantity as well. So now we have different types of physical, well, we have two types of physical quantities. We have base quantities, also basic quantity, and we have derived quantities, right? So let me use this pen as well, right? So you can see what I'm talking about, right? So the base quantities are, well, we know length, mass, time, and thermodynamic temperature, amount of substance. But let's first talk about length, mass, and time. So these are three quantities that you need to specify a state of your system, right? So you need its length, you need the mass, and you need time. So you can make a lot of quantities using these three quantities: length, mass, and time. And their units, now you can express units. There are multiple ways in expressing or writing units. Different I think countries use different systems. We have CGS system, we have this SI uh, system of units. So we'll be using SI units, right? So we know that for length it's measured in meters, mass is measured in kilograms. Now this kilo is an additional, you can say that these are two words, right? Kilo is different and gram is different. But your SI units have mass as kilograms, right? And then you have a time, which is measured in seconds, and thermodynamic temperature, Kelvin, amount of substance, mole. So we'll dig into these two later on. We'll be mostly working with these, and we'll derive some quantities from meter, kilograms, and seconds. And these are just their unit representations of these, right? So I don't think I have to go into any more detail uh, for this. So then I told you we have derived quantities as well. One of an example for a derived quantity is force, right? So I can give you this example, which is, what is force, by the way? I'm sure you know it, right? It's just mass times acceleration. So what is acceleration? I will dig into the main definitions of these quantities in further chapters. This chapter is a very basic physical quantities and units, so we'll be just using these words and we'll explain their definitions in the upcoming chapters, right? So we know acceleration is your rate of change of velocity, right? And velocity is your how your displacement or how distance changes with time. So you have x over t over t. So it's actually x over t squared, right? I'm just worried because this meeting will end, I think, and I don't even know how much time is left. Can you see how much time is left for the meeting?
3 minutes and 1 second.
Okay, right. So when there's just 1 minute left, just let me know. Okay, I cannot see it on my screen right now, so I'm sorry for that. Right. We have acceleration as x over t squared. So what are the units for acceleration then? We know what are the units for x. It's just length.
S minus 1.
Yeah, exactly. No, m s. What should it be, right? You can see the expression for acceleration is this thing. It looks something like this, right? So what should it be? ms minus 2, right? So time, there are two quantities of time. So you have one, from one you have, let's say it's something like this, t times t, but t is s and this t is also s, and it's in the divisor, right? So x divided by t. So you have two s's, so that's why you have minus 2. So that's acceleration, and we know mass is kilograms. So the derived unit for force, by the way, we use these square brackets to write down the dimensions or units for that quantity. So we would have, for m, we have kilograms. For a, we have meters per second squared, right? So that's ms minus 2. So now we can also work out this example where it says, what are the derived units of density? Now, density is a derived quantity. What is density? Any idea? Just give me an expression for density. Yeah, exactly. So it's represented with the symbol rho, and it's mass over volume. Now, volume is a three-dimensional thing, right? So volume
are basically those that are derived from 2 or 3.
Exactly. So they're derived from
Centimeter cube.
base quantities. Yeah, exactly. But you can derive your derived quantities can also be derived from the derived quantities themselves, as we did this example for F equals ma. So a was derived from velocity, and velocity was derived from displacement. All right. So we'll just finish this example. So volume is a three-dimensional thing, right? So there is x, there is y, and there is z. So we have units coming from x. We have 1 meter From this, we have a unit that is another meter. And from this also, we have a unit that is meter. So when we combine these together, we get volume.